Right, this is the fourth video for physical science, waves and sound. I'm talking a lot about waves and sound. Sound waves are longitudinal waves that have to have a medium to travel through, and there's four basic ways we can describe them. We can describe their speed. Remember that speed is determined by the temperature of the substance you're flying through, for air specifically. But while sound does travel through air, it travels through solids best and gases the worst. So the temperature of the gas that you're flying through air, or that the sound is traveling through, is going to determine how fast it goes. We've looked at wavelength and frequency, how they are related, and together they have to do with pitch, the pitch in the sound that we hear, whether it's a high pitch or a low pitch. Is frequency and wavelength. Remember that a long wavelength is a low frequency and a low pitch, while a short wavelength is a high frequency and a high pitch. So the last thing that we need to talk about is amplitude. Now, one thing you may have noticed, if you're sitting in your car at a red light and an ambulance goes driving by and they've got their siren going, or like a fire truck or a police car, you may have noticed how the sound changes as the vehicle approaches your car, as it passes your car, and as it continues on down the road. So as that ambulance is coming toward you, you actually have a different pitch than what is really there. So if the object is moving toward you, the pitch you hear is going to be higher than it should be. So the pitch of when you're just standing there and that sound is standing there is going to be its pitch. If it's coming toward you, because of the way the sound waves radiate from that source, it's a high pitch. Now, as that ambulance passes you and continues on down the road, it's going to get lower and lower and lower the farther away it goes. This is called the Doppler effect, and that they can measure how far away something is based on how much its pitch has changed. And that's actually one of the ways that they can measure how far away something that's similar to this, and we'll talk about in another chapter, how far away objects are in space based on kind of a redshift, a Doppler effect in space, that things aren't quite the right color because of how far away they are. So remember, if you've got a horn blaring and it's standing in front of you, it's going to sound different if it's coming toward you and as it moves away from you. It's higher as it comes toward you, true pitch when it's next to you, and lower as it moves away from you. That is the Doppler effect. So volume of sound is going to be amplitude. When we talk about amplitude, we're talking about how loud the sound is. So if something has a large amplitude, the sound waves are going to be really loud. And if it has a small amplitude, your sound waves are going to be quiet. Have you ever noticed how when you're close to the sound source, the sound waves are really loud, the volume can be really loud, and as you move away, you haven't adjusted the volume setting on your speaker, but the sound waves get quiet as you move away. And the reason for that is because as the sound waves travel through the air, the amplitude decreases. So amplitude is going to be how tall the waves are as they're flying through the air. And so the height of those waves, well, it's not going to change the wavelength necessarily. The height of the waves are going to decrease, and amplitude is how tall your waves are. So think about if you drop a rock into a pond, your first ripples are going to be kind of tall, and as they move away from where the rock was dropped, they get smaller and smaller and smaller. The ripples do, the height of the ripples. So that is what amplitude is. As it travels away from the source of the sound, the height of your wave decreases, your amplitude decreases. So whenever you're turning up the volume on your TV or your radio, your headphones, what you're doing, you're causing that device to produce a larger amplitude so that it gives it more power to carry towards you. Now, extremely loud sounds can damage your hearing. Your cochlea inside your ear, there are some very delicate cells inside there, and loud sounds can destroy them and damage them so that you can damage your hearing. So anytime you are working around where there's got to be really loud sounds, you need to be wearing protection. So people who fire guns have to wear ear protection. People who are working in like construction are going to be wearing ear protection. Around jets are going to wear ear protection because they're very, very loud sounds, can hurt your ears. And once it's gone, it's not something that gets repaired by itself. And so you could possibly lose your hearing due to something that you might be having a really great time doing, like listening to your headphones really loud or going to rock concerts and standing up by the stage where the speakers are. But once you damage your hearing, you're not going to get that back. So one sign of damage to your ears is if you're always hearing ringing in your ears, that means that your ears have been damaged. You really should go see a specialist about that. All right, so the scale that measures how loud sound is called your Bell scale. Now, we don't generally refer to things in bells. We usually refer to them in decibels, which is going to be 1/10 of a bell. So each one bell is going to be a 10% increase in the wave intensity. So to go from 0 bell to 1 is like times 10. And then from 1 to 2 is another times 10. And then from 2 to 3 is another times 10. It gets big pretty quickly because it's times 10 each time you increase your bell level. So a 0 bell is going to be the lowest bell. It's going to be the lowest sound that we can hear. And 13 bells is up high enough where you would actually cause damage to your ears. So between 0 and 13 is generally what is considered on the human scale. Now, like I said, we don't really use bells very often. We usually use decibels. Deci meaning 1/10. And so it's much easier for us to quantify things in tenths of bells because within that single level of a bell increase, you can have a huge difference in the amount of intensity in the volume. Now, 0 decibels to 130 decibels is going to be the common range for humans. Just to give you an idea of where some of those are, if you're whispering, that generally will measure about 20 decibels on a device that is going to be measuring the Bell scale. Normal conversation is right about 40 decibels. If you're outside and it's traffic, if you were standing out on Pat Booker and there was lots of traffic, busy traffic is about 70 decibels, so it can be kind of loud, but not super duper loud. Power tools, a lot of them are right around the 80 decibel range. A gas-powered mower, if you're going out mowing your lawn, that gas engine is going to be about 95 decibels. At a rock concert, if you're sitting near the speakers especially, it's going to depend on where you're sitting, but a typical rock concert where they're playing the music really, really loud, sometimes that can be at a contemporary service at church. They like to play the music really loud. It's going to be about 115 decibels. Once you start hearing sounds that tend to start causing pain to your ears, that's possible right around 120 decibels. So that's just barely above a rock concert. And then anything at 130 is possible to damage your ears. So normal conversation, something that's comfortable for us to listen to, is right around 40 decibels, right around 4 bells or 40 decibels. There is a quiz tonight. Go ahead and click on that and take the quiz, and I will see you in class. Have a good night.